Hi guys, this video today is going to cover graphing the parent function of y equals b to the x power. So y equals b to the x power is a simpler version of y equals a times b to the x. So y equals a times b to the x would be sort of like the standard form in a way, whereas y equals b to the x would be the parent function. It doesn't have the a on it, and so it's a little bit of a simpler form. Let's start off by talking about y equals a times b to the x, and then we'll get into graphing. So in the function y equals a times b to the x, that is our exponential growth, or exponential decay, really, our exponential function. That's what it is. The a stands for the starting amount, and the b stands for the growth factor. And so I'll talk about these along the way, but like the starting amount is like an example we used a minute ago in the other video. You start off with a $20,000 car and it's decreasing by a rate of 10%. Well, your starting amount is going to be the $20,000 that you start with. And then the growth factor is going to have something to do with that 10% that it's decreasing every time. X, I have time in quotation marks, and the reason I have it in quotation marks is because it's not always time like seconds or minutes or years. Sometimes it's time as in how many times did you do it? So like that cell division example, how many times did it split? And so it's not per year or per second, it's how many times. So anyway, time is in quotations because sometimes it's years or seconds, sometimes it's how many times it did something. Okay, now this equation, y equals a times b to the x, if b is greater than 1, that is exponential growth. If b is between 0 and 1, that's exponential decay. Look at what we're talking about. We're talking about that number. If that number is greater than 1 and you take it to a power, it's going to get bigger. However, if that number is a fraction or between 0 and 1, then if you take it to a power, it's going to get smaller. Like 1/2 to the second power is 1/4. It's getting smaller. So that's what's going on there. And so that's how we can decide if something is growth or decay, is by looking at what is the number that's getting taken to the power, and that's how we decide it. Now let's switch our attention a little bit to just the parent function. Doesn't have the a in front of it. Actually, you could think of that there's an a of 1 there. It's kind of an implied number, and that 1 being implied might be important as we go through here. But let's take a look. What happens if we take b to some power? And so I have a table of values. I might start at the bottom because that might make more sense to you. If I take b and I put in a 2 here, obviously that's going to be b to the second, right? And if it's just b to the first, well, we just call that b. Now, anything to the 0 power. What is anything to the 0 power? Well, anything to the 0 power is 1. All right, what do we do with negative exponents? If I had a -1 over here or a -2 over here, what does that do to it? Well, the negative, remember, gives us a reciprocal. So if it's a -1, it's 1 over b. And if it's -2, it's 1 over b squared. And so that is our table of values. Now I realize with b, that's a little bit difficult for you to grasp. And so we will do some that have numbers in them. But let's actually start with this b, because there are some things that are going to be common in the graph. And that's why I wanted to do this parent function with just a b. Let's make some tick marks on our graph. I just made some tick marks on the graph. And I always have a point at 0, 1. You will always have a point at 0, 1. So there I have my point at 0, 1. Then on the left-hand side, I'm going to go to 1 over b, and then 1 over b squared. Well, I don't know what that is exactly, but it's a fraction, right? And then it gets an even smaller fraction after that. And on the right-hand side, at 1, I'm going to be at b. Now, I have no idea where b is because I don't know what b is, but it's a number and it's greater than 1. And my next one is b squared, so it's even higher. Okay, so I don't know exactly where these are, but I'm going to try to fit my curve in here. On this, there are always going to be these 3 points. -1, 1 over b, 0, 1, and 1b. I know that's kind of hard to read because my handwriting is a little bit messy. I was trying to fit it in there. But these are the points. You will always have these 3 points. These 3 points are very important points. Let's talk about the domain and range real quick. The domain is from left to right. Can you see that this is going to go from negative infinity to positive infinity? Now the range is not. How low can that range go? Well, if you know anything about this, you know, I think that you've learned this before in Algebra 1, it can't go below 0. 0 is like the asymptote. We'll write that down next. It can go up for infinity, and it's not going to include 0. It does not include 0 because our asymptote is y equals 0. Those domain and range are going to be common as well. Let's take a look at the next example. Okay, once again, I'm going to go ahead and make some hash marks on my graph over here. I'm going to fill in my table. This time the table is a little bit easier for us, I think, because we have a number and we understand those a little bit better. Again, let's start at the bottom. 2 squared, 2 to the first, 2 to the 0, etc. So 2 squared is 4, 2 to the first, 2 to the 0, 2 to the negative 1 is 1/2, and 2 to the negative 2 is 1/4. Okay, make sure that that makes sense to you. Again, we have this point, 0, 1. We have the next point, 1, and then whatever the base is, that's called the base. And so whatever the base is, and then the other one is negative 1 is 1 over the base. And so I'm going to take a second now to plot those 5 points on my graph. Okay, those 3 points are showing up again. That is the negative 1, 1 over b, the 0, 1, and the 1b. Those 3 points will always show up. Those are the easy ones to find. It's kind of like when we did parabolas. We had that 1, 3, 5 pattern, and if you knew that pattern, it made it easy to graph. Same thing here. If you remember this pattern, it's going to make these a little bit easier to graph. And so they will graph like this. Once again, we can see the domain is negative infinity, positive infinity. The range, again, it's never going to get down to 0. Half of this is a fourth. Half of a fourth, eighth. 1/16. It keeps getting smaller and smaller fractions, but it never actually gets to 0. On the right-hand side, it can go to infinity. Excuse me, on going upward, it can go to infinity. And then the asymptote is, again, y equals 0. It's not going to go below that. That's what happens with exponential growth. So we said in the beginning that whatever that base is, if that base is greater than 1, it will be growing. If that base is a fraction between 0 and 1, it will be decaying. And so this one, the base was greater than 1, it showed us growth. On this next example, our base is less than 1, so it's going to show us decay. Take a second to fill in the table. This has a fraction this time, so it might be a little bit more difficult. All right, let's talk about that table. Once again, 0, 1, always there. Now, we know, I think, that anything to the first power is itself, so that's the 1/2. Once again, that is the 1, b. The next one, if a 2 is there, that's a 1/4. All right, remember with the negative powers, that does not mean a negative number, it means you flip it over. If it's negative first power, we flip it over. If it's negative second power, we flip it over and we square it. And so this is our table of values. Let's take a second to graph that. Okay, let's look at what we have. Once again, I have that negative 1, 1 over b, 0, 1, and 1, b. Those are the 3 anchor points that we're going to use. And I've got the rest of them graphed. My drawing isn't very good. I had a hard time with my pen there. So I think you understand what it's basically supposed to look like. This is pretty close. Once again, our domain is still negative infinity to positive infinity. Our range is still from 0 to infinity. And our asymptote is still y equals 0. And so that's going to give us this graph. Pay attention to a couple of things. Notice this graph obviously is going up because of exponential growth. This one is coming down because of exponential decay. Notice they both have a 0, 1. They both have that same y-intercept. And then the other part, they're essentially just kind of reflected from each other. Okay, so just keep that in mind as well. Another thing, just real quickly, in some of the assignments that we're going to be doing that go with this lesson, there will be a little bit with high-vote transformations. Let me just briefly talk about that. I might do it with that first example because it's a little bit more simplistic. Let's say, and you don't have to write this down, or you can if you want to, let's say there was a +5 on the end. what would that do to our function? It is outside. It's not inside, it's outside. And so since it's outside, it's going to move it up 5. So in other words, I used to have an asymptote at y equals 0. My new asymptote is at 5. So 1, 2, 3, 4, 5. And my old intercept was at 0, 1. My new intercept is at 0, 6. I'm adding 5. I add 5 onto here, and I add 5 onto here. And so if that's 5, then here's 6, and that's my point here, and my graph is going to look something like this. Okay, so just a quick reminder of how the HIVO works. Outside means up and down. If it was inside, that would be like this. And what would that 3 be doing in that case? Remember, that would move it right 3 units. And so a similar deal, the only asymptote is going to stay where it is, but each of these points is just going to scoot over 3. And again, I think if you draw this, it's going to be kind of junking up your graph too much, but I can move this over 3 points, and I can move this over 3 points, and so forth, and I would have a graph like this. Okay, so just a little bit of review of HIVO. I don't think we get into that a whole lot in the problem set, but there's a couple of them maybe that I want to make sure you did see that. Okay, that is the end of the video for today. And again, there's a couple of problems for you to do. If you have questions, bring them to the next meeting and we can talk about questions.